talk about the Kemp Dell EMC ECS solution. So again, my name is Frank Yu with Kemp Technologies. We do load balancing technology. And what we're doing today in this section of the presentation discussion is we want to talk about the Dell EMC ECS Elastic Cloud Storage Solution and how the Kemp load balancing technology is incorporated and why we're incorporating it with the Dell ECS solution and why it makes sense. Okay? So it's a joint solution where we are a select partner with Dell, which means there's a lot, it's not just marketing and buzz, there's a lot of technical integration and back-end work to make this happen. So Dell EMC has their ECS Elastic Cloud Storage Solution, which is their object storage solution product. And they're doing it just for the reasons that we've been talking about, where we want to modernize the applications, modernize the way we deal with the file storage and the objects and managing it from the different use cases like the archiving purposes or for security, for data protection, providing better accessibility, adding the metadata tags so that we have more relevant information related to those files as examples. We want to lower their storage costs, of course, so we make it more flexible because now when we go to object storage, all we have to do is add disk, add memory to be able to expand and scale. Makes it much less expensive. And we want to accelerate the cloud native applications. We want to accelerate the capabilities of these traditional file storage systems, which might have been more linear in terms of the way they worked and more user interactive, and make it more driven by the applications and driven by the customers and the use cases to be able to get better performance and better reliability for customer experience, application experience with these environments. And at Kemp, what we want to do is we want to help, on the right-hand side here, we want to help take advantage of this object storage solution benefit that the customers want, and we want to maximize the value. And how do we maximize the value? We optimize the performance and capabilities of the ECS solution using the load balancing technology. We want to do things such as provide the scalability and availability. We want to improve the resilience. We want to provide the DR active-active capabilities. We want to do the SSL offload so we can offload that encryption performance requirement off of the ECS environment, which is designed more for object storage and management, to these network CPU intensive heavy process of SSL key management and encryption decryption to a device or technology that is better suited for it, such as the load balancer. And we want to enable cloud storage scalability. So again, that load balancer, by being that reverse proxy in front of the ECS nodes and in front of the storage system, gives you more flexible capabilities in terms of adding and removing maintenance without impacting user experience.
Just to clarify, yes. You said more than. So is that compared to the integrated load balancing solution, and what specific value does Kemp bring to the table versus that integrated load balancing?
Yes, we are going to get there. We are going to talk about that, but absolutely, let's touch on a little bit. So what we want to do is we really want to make sure that, because like any integration, when we talk about different technologies and different vendors and things like that, we want to optimize the technologies to work together better, right? So cloud object storage solutions exist today. Load balancing technology has been around for over 20 years. But until somewhat recently, we haven't really started seeing what can we do to take advantage of each other to make things work better. Load balancing, we could just do basic load balancing of traditional TCP and do the reverse proxy, but there are added benefits that we could possibly do that are specific to the object storage technology that makes sense. So we want to make sure and work with, for example, in this case with Dell EMC, to make sure that whatever technology advantages we can take advantage of, we want to make the performance of both of them work better. As that whole, and this is a cliche, 1 + 1 = 3, right? Where you have the two separately, but when you put them together, we're going to get an additional benefit. There's a synergy by bringing them together. Does that make sense? So when we talk about the solution, and this is a logical overview real quick, we have the object storage architecture, and you can see here in the object storage architecture, we have, first obviously, we have hardware. People always like to say, oh, everything's virtual, everything's in the cloud. Ultimately, everything sits on hardware somewhere. There has to be hardware. So we have the hardware, and then we have the infrastructure. I have a service provider background, so I would call this NFVI, Network Functions Virtualization Infrastructure. It's the compute network storage component necessary to bring everything together. And then moving up the stack, not OSI stack, moving up this stack, we have the fabric, which is the cluster management, the checking, the health monitors, the API components, so that the Dell ECS solution can provide benefits and understand what's going on within itself. Then we have the storage engine itself that provides the data protection, replication, provides the management of the file storage and other pieces. On top of that, we have the data services. These are the APIs and applications such as S3, NFS, Atmos, etc., Swift. And we have the UI for the access for the interface for the portal.
What's the /12 doing there? What's the function of that piece?
I'm not sure what the /12 is. I have to admit.
SUSE Linux.
SUSE.
Yeah, it's SUSE Linux. But I'm just kind of curious, what's that piece doing there?
I'm not sure. This is part of the Dell. This is the Dell piece. I don't know if you know more.
You're not right.
Because it's very specific. It didn't just say Linux.
This is something that Dell has produced that we're leveraging for the information.
I'll go and check it out.
I apologize for that.
No problem.
And then, of course, we have the front-end management. So the management, similar to centralized management, of course, for ECS, there's a centralized management function that incorporates providing dashboard, configuration management, et cetera, for the ECS environment at a global level. So again, it's not just per node, per event, it's for the entire infrastructure that's been centralized. So this is what we have from the Dell piece, and then when we talk about integrating the load balancing and the load balancing capability and what we want to do here, there we go. The load balancing use cases for ECS, we broke them into 4 key categories. Number 1, high availability. We want fault management. We want to be able to detect if there's a failure in a node, failure in a site, and that failure could be unplanned or could even be planned for maintenance windows, et cetera. So we want to be able to do the proper checking and monitoring of these different components in the ECS infrastructure. And if it's something that's not available, do not send the applications and the clients to those nodes or those components that are not available. So we do that automatically, dynamically, by doing the health checking of the application and the service to make sure that it is available if we're going to send traffic to it. Global load balancing. Global load balancing is a step up, is actually a core component in terms of load balancing technology. But what global load balancing is really roughly dynamic DNS, where we're manipulating DNS to be able to steer traffic to different sites. Somebody makes a DNS request, we'll respond, and we'll respond to a specific response to go to a site based on availability or for DR purposes, active standby. We can provide the distribution across these multiple sites. The third piece is security. We want to do primarily that SSL offload because SSL or TLS or whatever you want to call it nowadays, I should say TLS because SSL died when it became 3.0, TLS 1.0, right? And we want to offload that heavy lifting of key management, certificates, encryption, decryption from the storage system, again, to the load balancer, which is well designed and has specific hardware such as those Cavium Nitrox or other types of accelerators for that SSL acceleration performance. And last, IPv6 v4. Not everybody's using IPv6 today. A lot of enterprises are not, but there's a lot of IPv6 in the world today. Carriers are using v6, federal government is using v6, and ECS today is designed as a IPv4 technology. It's not designed for v6. So if you have a v6 environment, you need some sort of NAT gateway, network address translation gateway, to do the v6 to v4 translation, and the load balancer can do that. Yes?
So to be clear, that's IPv6 out to the rest of your environment, but IPv4 behind.
That's correct. So ECS to the load balancer is v4, and then S3 or whatever application on the outside to the load balancer on the outside, that's correct, it would be IPv6. Okay. And this reference architecture diagram is a logical view of how everything is now put together. You can see here on the right-hand side, we have the ECS nodes. This is where everything is stored in terms of the objects. And we have 2 sites here, New York and Las Vegas. And we have a LoadMaster load balancer load balancing the nodes in each site, or maybe a pair of load balancers for high availability. But we have the load balancer managing the traffic distribution to the nodes for that availability, fault detection, et cetera, that we discussed. And then on the left-hand side here, we have the various applications, again, whether it's S3, Atmos, Swift, NFS, and these applications now communicating through the load balancer to the nodes in the different sites. And they're doing this most likely encrypted connection on the outside and unencrypted on the inside is usually the way it's designed. And like we were saying earlier, if it's V6 to V4, V6 on the outside, V4 on the inside. And this is in general how we're going to provide that high availability for the sites and for the ECS nodes and the ECS units. Okay? And at this stage, I would love to pass it on to Kurt, who is our technical wizard. And Kurt's going to talk a little more and provide a demonstration. Yes, sir.
Quick question about data consistency. So here in that previous diagram, we're accessing data from potentially 2 regions simultaneously. How do you make sure, and what about ECS allows you to do that?
Actually, if we can hold that question until later, because we're going to talk about that. Multi-site and routing traffic to the data consistency and all that stuff later on. So if we can just hold that's a great question, and I definitely want to get to that. So thank you. My name is Kurt Jung. I'm a senior technical marketing engineer at Kemp. I'm going to take you through this demo. I want to kind of set the stage, what we have here. So this demo, I want to focus on setting up and publishing ECS through the LoadMaster. So over here we have our apps, we have our load balancers in the middle, and then we have our ECS nodes on the right over there. And we have our single namespace ECS. And as you can see, we have the traffic coming into the load balancers on port 443, and we have the traffic coming out to the ECS nodes on 9020, which is the unencrypted port for S3. Now, to focus in on the load balancer in the middle, there's a lot of things, and Frank was talking about this before, there's a lot of things we can do on the load balancer. There's a lot of complexity and a lot of complex configurations we can do on this. So, a bit of a story, prior to Kemp, I worked as a consultant at a small systems integrator out of Jersey, and I focused on Exchange and Skype for Business and SharePoint and things like that, which all require load balancing. And we weren't partnered with Kemp, we were using some other load balancers. But as the lead engineer, I was the subject matter expert on load balancing. And whether I really felt like an SME, that's debatable, because it was just so complicated and complex to get these configurations working. When I got to Kemp, I realized there really was an easier way to do this. And what we're going to end up doing, that's based on Kemp's intuitive web user interface, our clear documentation, and most importantly, our application templates. So we have this concept of application templates, which are used to set up virtual services for many different workloads. And it's all based on best practices. We work with our partners like Dell EMC on ECS to make sure that we're doing the best availability, the best performance, and the best security. So let's go ahead and jump right into the demo. Okay, so here we are with in our LoadMaster. So the first thing I'm going to do is I'm going to go over to our website to download the application template. So just going over to resources, documentation. Over here we have all of our deployment guides, and on the right over there we have our templates. So you can expand some of these out. You can see within each of these we have I think we have 80 plus application templates for different workloads. So I'll just go down to Dell EMC. We could pull the ECS template. I've already downloaded it. So if we jump back to the load balancer, I can go to virtual services, manage templates, go ahead and browse, select the template, and import it. What's this going to do? It's added actually 17 templates to the LoadMaster. So this is all depending on how the customer is set up in their environment. So we have obviously the Atmos, the S3, Swift, and NFS, and we also have configurations based on layer 4 load balancing or layer 7 load balancing. So if they're doing any kind of offloading or anything like that, we're obviously talking doing layer 7. If they're not, they can use layer 4. And we also have a load balancing template for the web interface for ECS. So I've already went ahead and I've added some certificates prior to this that I can use so I can do that offloading or re-encrypt depending on the template. So I'm going to go ahead and add a new virtual service. I'm going to go ahead and put a new virtual IP address in here. I'll go ahead and select the template. The first one I'll do is I'll do the web interface. It's going to already populate the port, and I can just update the name, and I can update the port here as well if I wanted to. So I'll just do that, add the virtual service. Now, if I go back, this template actually creates 2 virtual services. The first one is just a redirect. So customers don't have to put HTTPS. It will just automatically redirect. So if I go into the 443 virtual service, I go to SSL properties. All I need to do is select the template, or select the certificate, set it. And as you can see, we are doing re-encryption on this one. Pointer's not working, but we are doing re-encryption there. You can see on top. Then I just have to go to the real servers. I already have all the health checking, everything set up. I just have to add the IP addresses for the ECS nodes. Now, we could also do all this automated. We have a rich RESTful API. We can do this. We have PowerShell wrappers and all this stuff. But we really wanted to go through the process of doing it manually to kind of get the real feel for LoadMaster. So I'm going to go ahead and add a second one. This one, I'm going to add another virtual IP address. And this one, I'm going to select the layer 7 S3 offloaded. Once again, I'm going to give it a unique name. I'm going to keep the port at 443, but again, I can change that. And then again, I just need to go through, go to SSL properties. I'm going to select the certificate. This time, you can see we aren't re-encrypting. We're doing offloading on this one. And then I just need to go down and add, oh, sorry, before I do that. So this is very important. So within the advanced properties, since we're doing layer 7, one of the things we want to do is, because we're terminating the connection on the load balancer and then establishing a new connection to the ECS nodes. So what does that mean? The ECS nodes are going to see all the traffic come from the IP address of the load balancer, not the source IP address of the application that's accessing the storage. The problem there is if a storage admin is trying to troubleshoot a problem and he goes into the logs and he starts looking to see what's going on, he's just going to see one IP address. It's very hard to troubleshoot something like that. So what we're able to do is we're able to use the X-forwarded 4, which we can obtain the source IP because, again, we had that communication with the application. Take that, we'll add that to the header, that source IP address, and then send that to ECS. And then ECS will take that IP address and then can use that for their logging and then have that in their logs. So they can, again, continue to get that IP address for troubleshooting purposes. And now we just need to go down and add the real servers, add those nodes again. And this time I have to make sure the port is on 9020, that port for unencrypted traffic to S3. And that's it. So our configuration is complete. We've created a virtual service for the web interface. We've created a virtual service for S3. And we're all ready to go. We're just going to let that validate. Everything is healthy. And now what I'm going to do is I'm going to bring up my client, my so-called app. And the first thing I'm going to do, I'm going to go to the web interface. I need to get some information from there. So I'm going to go to webui.kempdemo.com. I'll go ahead and log in. So what I'm running here is I'm running a community edition of ECS. So it's great. I just download it from GitHub and an OVA and just deploy it right in VMware and get a system up and running. So here we have our dashboard. We see we have a 2-node environment here. We have some analytics on performance, some requests, capacity. I have 300 gig per node, so I have a total of about 600 gig there. So if I go to manage and users, I need to authenticate to access the storage. So I'm going to use this object user 1. So I go and edit that. and I need to get the secret key. So obviously what this means is that I don't follow instructions. So this is the default with deploying the ECS Community Edition, the YAML file. You can go in and actually create new keys as well, depending on how I want to run this environment. But for lab purposes, I just left the default. So I go ahead and copy that off. And now I just need to go to the desktop. I'll launch my S3 browser, create a new account. I'll call it Kemp. I'll use the S3 compatible storage. My REST endpoint is ecs.kempdemo.com on port 443. The access key ID is that object user 1. And I just need to paste that secret super secure key in there. And then I just want to make sure that I'm using secure transfer. And now I'm connected to the ECS environment. And in here I can create new buckets, drop files, as well as over here in the management buckets, I can create buckets here as well to manage them.
I have a question.
Sure.
More from, from the fact that I'm really ignorant about this technology. I mean, in the past, when I deployed Object Store, I always used HA proxy to work it perfectly. You have your Ansible script. Most of the cases, you just deploy it, works. Many data centers have it. What is the differentiator? Because most of the features that I see in this demo are available from all the other load balancers in the market, not only open source one, which means free somehow. Okay, so what is the real difference? What makes this different, especially on the ECS configuration?
Absolutely, and that's a great question because load balancing technology is mature in general. It's been around for 20 plus years, ever since Local Director came out in '97 from Cisco. If you remember those devices, I do. It's a painful memory, but that's okay. But what's different is there's two pieces that are different. One is that, especially talking specifically about HA proxy, is that its load balancing capabilities and advanced capabilities are somewhat limited because of the nature of the product and being open source for the most part and everything else. So there are some advanced things that you want to take advantage of that you potentially couldn't have. For example, doing the SSL offload is much harder to do or much more challenging for high performance with an HA proxy environment. The second piece, so there are little technical components that make it plus or minus in terms of advantage or disadvantage, for the different solutions. But the other piece that's really important is going back and talking about the integration that we've done specifically with Dell EMC for the ECS, where we've done a lot of technical validation, and these templates that Kurt described and talked about are critical because we have talked to customers that have ECS solutions that aren't using Kemp or are using a different vendor, other vendors which I will not name. But the difference is because we've done so much validation and configuration management and templates and everything else that it becomes really a turnkey operation.
Okay, so it's optimization.
Optimization, that's absolutely correct. Because like I said at the beginning, I believe, if you go to if the storage guys are deploying an object storage solution like ECS, and they go to the load balancing team and say, we need to load balance this, the first statement out of those load balancer guys' mouth, and it would have been mine back in the days too, is, why are we load balancing storage? That makes no sense. In the old days, that didn't make sense. But the world has changed, this has changed. So it's really a lot of applying the knowledge and the integration of how we understand how this object storage works and making sure we apply the technologies correctly. And we do that very tightly with EMC.